Hello and welcome back to the video lecture series on Python programming. Today we are going to look at the Python libraries. This is the most important feature of Python, that many of the reusable functions which are extensively used for different types of activities, we are going to go through each of them. They are being already given in the form of the libraries and the functions, right? So once you have a good idea about the Python libraries and what all features and functions they provide, you'll be in a pretty good position to do a lot of coding with a very less amount of effort, right? So what are the different libraries that, the important ones which Python has? The first and foremost library is the Numpy library. It is the library which is there for the different numerical operations. So a bunch of numerical functions, statistical functions are being provided by the Numpy library. Then you have the pandas library. We all know that a lot of activities are related to data need to be done as a part of things like machine learning and deep learning, right? So when you work with data, there needs to be very specific custom functions which needs to be there for working with the data, for the manipulation of the data and stuff like that. So for that, pandas provide a lot of functionalities. Then comes a couple of libraries, matplotlib, and based on matplotlib, there is a more advanced library called the Seaborn library. Both of them are used for visualization. So whenever we talk about data, a very important part of the data, very important function related to data is visualizing the data. So for that, Matplotlib provides a lot of graphs and other pictorial tools to visualize the data. And last but not the least, but this is going to be more related to the machine learning part of it, is the scikit-learn library. Mostly the statistical and the machine learning related functionalities are provided by the scikit-learn library. At the same time, certain other pre-processing stuff, which is not directly a part of the machine learning activities, but it's more of like a precursor of the machine learning activities. Those are being supported by the functions provided by the scikit-learn library, right? So these are the five most critical libraries that you need to be aware of. At least you need to have some bit of an idea. Obviously, there are a lot of details which cannot be covered as a part of this particular lecture series. But at the very least, the intent is to get you familiar so you can start with it. Okay, then you have to navigate further and do other things. But at least you can start with these libraries, right? So without more delay, let me start with the first library, which is the Numpy library. As you can see, Numpy library has its name from the phrase numerical Python. So num from numerical and py from the Python. Combined together, NumPy, which is for, it's a basic package for all the numerical operations and statistical operations which are to be done by the Python programming language, right? So anything, linear algebra, probability, what all things that you can think about, numerical things are being covered as a part of the NumPy library. At the same time, there is another very important thing. It also provides a very important data structure. It's not a data type, it's a data structure, which is the array. We all know about array from our C++ or C programming days. In case you are not familiar with programming, there is something called arrays. We are going to be looking into arrays very soon. It's a form of a data structure. It's a structure which holds data, right? So NumPy library provides the basic array data structure, right? Which can be used along with the other data types which are already there, which we have already discussed. And another very important aspect is whenever we will look at the scikit-learn library, which is used for machine learning. So in scikit-learn, you will see, since we are going to be doing a lot of data munging and all, so in scikit-learn, NumPy arrays are the basic data formats or basic data structures which are being used. So whenever there is a data operation which is there, the expected format is a NumPy array, right? So that is why it is also very important to understand the NumPy library as well as the NumPy array data structure very well, right? Now, getting into the arrays, that's a very basic thing that we need to understand at the onset itself. So what is an array? It is basically, if you look at this picture, you will understand yourself, but it is basically a contiguous memory location. So you can see that there are one after another, there are different memory slots. So 201, 202, 200, 201, 202. These are like symbolic numbers which we have assigned. So these are contiguous memory blocks, and it's in each memory block there is a particular value which is being held, right? And again, other than the memory location, you can also see that there is an index which is being attached, and the index is pretty much like a sequential data index. When we have seen the list or the tuple or the strings, even we have seen, right? First element has an index 0, second element has an index 1, and so on and so forth. So like this array also, the index is in the same way. It starts with 0 and then continues with 1, with increase of 1, right? So it's basically a contiguous memory location which basically keeps homogeneous items. This is very important. It is able to store data of a specific data type, right? So homogeneous data it is able to store in the contiguous, or basically one after another, contiguous memory locations. Objective is very simple. It wants to store multiple items of same type. Same type. This is very important thing that you have to know. Same type that you want to keep together, right? Next thing is array. I mean, just if you can, I mean, if you are uh, already well versed with arrays in C or C++, it is fine. For people who are new to programming, just think about arrays as the different stairs. You need, I mean, you have seen a staircase, so you look at the different stairs, right? Each of these stairs can be thought as a memory location, right? And each of the stairs, you can assign a number to it. Location 1, location 2, location 3, like this, right? So each of the stairs, if you say, for example, if you put in a particular value, so on the location 1 you put in a value, say 25. In the location 2, that is the second stair, you put in a value, say 51, right? So you locate, I mean, you put in the different values in the different locations, which are the different stairs, right? Now when you basically want to access a particular value, you'll just give that stair number to access that particular value, right? Now that way, when you give a particular value, say for example, when I give a I mean the stair number 5. So what it will do, it will simply jump. It will not move across 0, 1, 2, 3, 9, all those things. It will go through to the staircase number 5, and it will take the value, which is, say for example, 35, and it will fetch that. So what is the advantage? Advantage is you can access the value in a particular stair just if you have the serial number of that particular stair. You can immediately get it, and it's very easy. It is very fast, right? So that's a very big advantage of a array, right? Now, that's what exactly has been recalled here. Random access of elements is very fast. Okay, it is position based, so it is very fast. But there are a couple of disadvantages also. The first disadvantage is right at the beginning when you are trying to define an object with a data structure array, NumPy array. Right at the beginning, you have to mention the size, right? So you have to mention how many number of stairs is it going to have, right? So size you have to define right at the beginning, and then after that you cannot change it. So that becomes kind of fixed. So you can say that it's a bit rigid. I mean, it's that way. That's one disadvantage if you call it that way. The other disadvantage is you have to put in elements of the same data type. You cannot put in elements of the different data types. So you have to, if you want to put in integers, you have to put in all integers. If you want to put in float, you have to put in floats. All the locations you have to put in floats only. You cannot mix up between integer and floats. That is not being allowed as a part of your array data structure. So this is a very important point, and this is noted as a disadvantage. Obviously, that flexibility is not there. There is a very common no, before that. So there are three types of arrays, or maybe more types of arrays. We can consider like three types. One is a one-dimensional array. Only you have the single dimension, and you have the cells or the array locations one after another. This is a one-dimensional array. The second type is a two-dimensional array. You have rows as well as you have the columns, right? The rows basically indicate the breadth and the columns indicate the length, right? So there are two dimensions, right? Then you can also have a three-dimensional array where you have the rows, right? You have the columns, and you have a third dimension, which is basically the depth, which indicates the depth. So the length, the breadth, and the depth. So that's a three-dimensional array. You obviously can have arrays of even more dimensions. That is also permissible, right? But for the time being, just for the sake of visualization, we can consider that there are three types of arrays: the one-dimensional, the two-dimensional, and the three-dimensional arrays, right? One of the very basic questions like people have, that okay, fine, arrays give us a contiguous set of locations where I can store my data, but same thing is being provided by a list also. So what are the merits and demerits of arrays as well as lists? So I mean, how do they compare with each other? That is one question they have. A second question, which has like a follow-up question, is in case I have to adopt one of these two types or data structures, which one should I go for? What is a basic guideline? So let's try to look into it one after another. First one, between the list and the array, how do they compare? So the first point is the Python list can can contain elements belonging to different data types, whereas arrays can contain elements of a particular data type. So that way lists are more flexible, arrays are less flexible, right? Second point, you need to explicitly import a array. I mean, you have to explicitly import the Numpy library to create an object of array data structure. Whereas for list, you don't have to do anything. You don't have to explicitly import a particular module or library, right? You can simply use the list by using the braces. You can initiate a particular object to a list data type, right? The third thing, arithmetic operations cannot be done on a list data type. Say, for example, if I want to do an element-wise subtraction or multiplication or division between two lists, that is not permitted. Whereas in case of NumPy arrays, you can do direct arithmetic operations. Directly, you can do the arithmetic operations. This is again a flexibility of the NumPy arrays, right? Next, nested, you cannot have, you can have different types of elements as a part of the nested, as a subpart of the lists, right? Whereas, uh, again, this is a very, very big important point. You must have the nested elements of array which need to be of the same length. In case of list, you can have a list as a part of an element of, as an element of a list, and each such list can be of different element, or can be different number of elements of different lengths. So one particular list, which is a nested list, can be having 5 elements. Another list, which is a sublist or a nested element of a list, can have 3 elements. Both of them can be an element, right? But that is not permitted in a case of a NumPy array, right? This is another big difference. In this case, list is again much more flexible. We prefer lists when we have a shorter data structure, shorter length of the data item. So the number of elements of the object is less, then only we can go for lists. Otherwise, it is better to go for array, and that is kind of hand in hand with the next point, because access or updation, or which means deletion or addition of elements in an array, it is much difficult, much easy, but in case of list it is much more difficult. That's why only when you have a particular object having shorter length, you will go for a list, because otherwise accessing or updation takes a lot more time. Whereas in case of a longer sequence of data items, you go for a array, because that way it is much more flexible to do an updation, or I mean, if you want to access a particular element, that is also easy, right? Lists consume much more memory, because it has to have a provision for being able to store any data type as a part of its elements. Whereas arrays are much more compact in size. It knows that what type of data it is going to hold. So that's why it is very much clear in terms of the memory it has to allocate. So the memory management is much more efficient in case of a NumPy array. So that way we know there are some pros, some cons. The pros for arrays are, it is much more efficient in terms of memory handling. It is much more better in terms of accessing the different elements, or updation or deletion. Uh, now, uh, the updation and deletion, though it is much more easier in case of list. In case of array, it is much more difficult. But access is much more easy in case of arrays. It is difficult in case of, it is not that easy in case of list, right? Uh, like that, the lists also have an advantage, that it can store data of any type. That is number one. Second, it can make the updates, that is the deletions or the additions, much more easily than in case of arrays. Third, it doesn't need to fix a particular length right at the beginning. It can keep on appending elements. There is no restriction to the number it can grow to, right? So when should I go for list? When should I go for array? Again, I've just given here a basic guidance. It might change from situation to situation. So whenever the sequence of data items is shorter, right? And they are like heterogeneous. You can have different types of data as different elements. Then you should prefer to go for the lists, right? Whereas when the sequence is larger and there is a lot of intense mathematical calculations involved, specifically those calculations like additions or subtractions element wise, then and also there's a need for memory optimization, then you should go for NumPy arrays. That is much more flexible, right? So now with that, we can start with the array creation. How to create arrays and how to do the different manipulations over array. Okay, so we will continue doing that in the next video. So stay tuned. Thank you very much.